Alright, this is Honors Geo, Chapter 3, Section 6, Prove Theorems about Perpendicular Lines. Alright, a lot of theorems in this section about perpendicular lines, and with that comes some proofs. So, the first one that they give is Theorem 3.8, which says that if two lines intersect to form a pair of congruent angles, then the lines are perpendicular. The conditional is if one is congruent to 2, then G is perpendicular to H. The thought process behind this is that if I know that 1 and 2 are a linear pair, then I know that they're supplementary. So I know that 1 plus 2 equals 180. If I know that 1 is equal to 2, then they both must be 90 degrees. If they're 90 degrees, then they're right angles, and if they're right angles, then they're perpendicular. So the lines must be perpendicular to each other. Theorem 3.9. If two lines are perpendicular, then they intersect to form 4 right angles. They tell me that these two lines are perpendicular. Here's the conditional. If A is perpendicular to B, then angle 1, angle 2, 3, and 4 are right angles. So if I know that they're perpendicular, then I know that they form right angles. I know that angle 1 is perpendicular, and then 1 and 4 are the same, and then 1 and 2 are linear pairs that are the same. And 2 and 3 are vertical. So we can say that all of these guys are the same. Theorem 3.10 says if two sides of adjacent acute angles are perpendicular, then the angles are complementary. Alright, with this guy, what this one's saying is if ray BA is perpendicular to ray BC, then A and 2 are complementary. So what they're saying is if BA and BC, AB and BC are 90 degrees, then angle 1 plus angle 2 equal up to those 90 degrees, and that makes them complementary. And here's the proof, and it's a 6-step proof. And they tell me here that ED is perpendicular to EF. First step. If I know that, then I know that DEF is a right angle because of you can use two definitions here. You can use definition of perpendicular lines, or since they're trying to get you to use theorem 3.9, you can say perpendicular lines intersect to form 4 right angles. Either one is correct. They're sort of interchangeable. If they're a right angle, then they equal 90 degrees, definition of right angle. Angle addition postulate, I know that 7 and 8 equals DEF. Therefore, I can substitute 90 for DEF and say that 7 and 8 equals 90 degrees, and if they equal 90 degrees, then they're complementary. Definition of complementary angles. It says, given that ABC is congruent to ABD, ABC, ABD, explain how you know that 3 and 4 are complementary. Or what I know. I know that 3 and 4 are complementary. If ABC is congruent to ABD, I know that they form a linear pair, and if I know that they're equal, then the theorem that we just learned, 3.8, says that they form, then they're perpendicular, which means that they form 90-degree angles. So I know that ABC is 90 degrees, and I know that ABD is 90 degrees. If I know that ABD is 90 degrees, then I know that 3 and 4 are complementary due to theorem 310. It says to write a plan for proof of 3-9 that if two lines are perpendicular, they intersect to form 4 right angles. So when you think about a plan, the plan is that you know that they're perpendicular, right? Theorem 3-9 says that if I have 4 intersecting lines, then they're all right angles. When you start thinking about a plan about these, the thing that pops into my mind is I know that they're perpendicular, so I know that these guys are all going to be forming right angles. I know that perpendicular means that they're 90 degrees, so I can say, using 3 theorem definition of perpendicular lines, that one of these guys is a right angle, and I can use various things to say that they're all right angles. So that's the interconnection between perpendicular and right angles that we already have been given before. Perpendicular transversal theorem. Perpendicular transversal theorem says this: if I have two perpendicular lines, if I have two parallel lines, and I know that the transversal, one of them is perpendicular to one of the transversals, then I know that the other line is perpendicular to it. So what does this mean? If H is parallel to K, then J is perpendicular to K, and J is a pair of parallel lines. I know that this guy is perpendicular. Then I know that this guy is perpendicular. You're like, why? Well, we can use, eventually you'll see in the proof, corresponding angles to say that these guys are the same. If I have a pair of parallel lines cut by a transversal such that line H is perpendicular to line J, then line J is perpendicular also to line K. Lines perpendicular to a transversal. So this is basically the converse of 311. Lines perpendicular to a transversal theorem. If two lines are perpendicular to the same line, then they are parallel to each other. So if I have two lines cut by a transversal such that line P is perpendicular to N and line P is perpendicular to M, then those two lines have to be parallel. Okay. Drawing conclusions. Determine which lines, if any, must be parallel in your diagram. So I see, if we just isolate this transversal S across P and Q, they form perpendicular lines here. It's perpendicular to S is perpendicular to Q, S is perpendicular to P. Since they're perpendicular to the same transversal, then these guys must be parallel lines, P and Q. So I can say that P and Q is parallel. Likewise, I can say that Q is my transversal along S and T. And again, Q is perpendicular to S, Q is perpendicular to T. Then I can say that S and T are parallel. I don't have enough information to say U because I don't know what U is perpendicular to either way. Okay. Is B parallel to A? Yes, B is parallel to A. If you look at transversal D, D is cutting across A and B. So D is perpendicular to B, D is perpendicular to A. Therefore, they are parallel through theorem 312. Can I say that B is perpendicular to C? Yes. Yes, I can. If I look at line A, I can say that D is perpendicular to A, C is perpendicular to A, so then I can say that C is parallel to D. So I've established that C is parallel to D. That's step one. Step two, then I can say that if C and D are parallel, and I see that B is my transversal and B is perpendicular to D, then B must be perpendicular to C, and that's theorem 311. So I'm using two theorems. Theorem 312, lines perpendicular to a transversal theorem to prove that A and D, C and D are parallel. Then once I prove that they're parallel, then I can use theorem 311 to say that since B is the transversal and I know that C and D are parallel, if B is perpendicular to D, then B must be perpendicular to C. So yes, I can. A distance from a point to a line is the length perpendicular as the length of the perpendicular segment to the point of line. This perpendicular segment is the shortest distance between 2 points. For example, distance between line A and K is AB. Okay, so what is this saying? We have line K. We have a point B. We have some point A. And if I wanted to draw a shortest distance between A and B, I draw a straight line. This shortest distance between A and B is also the shortest distance between A and line K. And what this says is that this shortest distance will always be perpendicular. It's going to be a perpendicular segment to the line. The shortest distance from any point to any line will always be perpendicular to that line. That's all it's saying. So segment AB, which is the shortest distance from A to B, or line K, will be perpendicular to line K. That is all that thing is saying. And it will always be the shortest distance from that point to that line. Shortest distance will always be perpendicular. Okay. So you just have to get the distance formula. You'll get points and find out that their slopes are perpendicular and you get their lines. That's stuff that you guys can do. I don't feel the need to sort of go over it. You guys know the distance formula. The only thing you should know from here is the distance formula. And if you recall, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. To refresh your memory, distance formula. You also know that perpendicular slopes are, you guys learned this just now, or refreshed just now, that negative reciprocals of each other. And that's enough for you to do that section. And that's section 3-6. Hope you have a great rest of your day.